a straight line program is just going to be, I'm just going to make it a class, straight line program. I'm renaming things here and there, which isn't really that good, but it is what it is. So, straight line program will consist of the symbol table, init form make hash table with the test of EQ, and the accessor is going to be I'm just going to make it symbol table. And I think we'll start with that. So the symbol table, let me write documentation for this. A mapping between symbols and their representation as SLPs. So when we look in this table, we get the representation as an SLP, like I said. So if we do defun, how do I want to do this? Yeah, defun symbol representation of a straight line. How should I call this? I'm just going to call it S, and unfortunately they both start with S and symbol. So within the straight, I should name this to something else besides straight line program. Something like that, but that's so long. Naming is too hard. S and a symbol. Look up its representation. So its representation is necessarily going to be one of these SLP things, which I'm going to move to the very, very top. So we let the symbol table be the symbol table of our SLPS. Then we do a get hash value. Get hash the symbol in the ST, but we don't even need to extract it here. We can just do this. Return nil if it does not exist. So we can't ever possibly get nil from this in any other way. So I'm going to change this to symbol assignment. And then we want to be able to set the assignment. So defun setF symbol assignment of our new value as symbol, assign to the symbol the representation within the straight line program S. Again, S isn't really a straight line program, it's just the storage of it. Okay, so one thing we need to be careful of here is that we ensure that it does not have an assignment already. If we overwrite assignments, we should at least make a continuable error, because what that means is that now we are invalidating every other element of this table which contains a reference to what we're overwriting. So I'm going to look it up first, the symbol assignment of why is that doing this? So, oh, we need to let current assignment be the symbol assignment of symbol cond not null the current assignment. So if the current assignment is not null, then we need to make a I should do this when unless null current assignment, then we need to make a continuable error. Assignment anyway. Assign to it anyway. Otherwise, the symbol is already assigned to symbol. So now we don't need to do this check here. Okay, so once we check that it's not already assigned to, then we actually make the assignment. So value setf get hash the symbol within the hash table, the symbol table of S. We're setting it to the symbol assignment. We should check that the symbol assignment, the represent, what? I shouldn't have said symbol assignment, I should say representation. I should check that representation is actually, truly a straight line program. We are not allowed to assign to anything which is not one of these things up here. Alright, so this is the core of it, the meat of it. So we can create a, what do we have here? Set, yeah. We have the core of this. So we have the memory aspect of a straight line program implemented, and we can do symbol assignments and so on. But what we'll need to do is be able to actually take a straight line program and convert it to its real representation using our group protocol. So we have a bunch of, these things, and we need to turn this, map it essentially into our group representation. But before I do that, I'm actually going to I can actually implement part of our group protocol on this just for convenience. So I'm going to do that. I'm going to say def method compose. Actually, no, I can't do that because this isn't actually a part of a group itself, so I can't actually, even though it's possible to compose these, there's no originating group that I can dispatch on. So I'm just going to keep that as is. So now we need to do evaluation. So evaluation is is what I described before, where we evaluate our straight line program. Essentially, the input is a straight line program, and the output is the sort of normalized representation in the target group. So defun evaluate SLP, and we need our straight line program, which I'm just going to call S. you know what, I'm just gonna make the dive and rename this to straight line program. Why not just call it assignments? It's a little bit uglier, but what can you do? So given within the assignments S and the symbol, look up its representation within the so given assignments S and the straight line program SLP, program SLP, compute its evaluation. All right. Yeah, I can write these. I mean, I don't know how useful it is to define these compose SLP, which would be one SLP, two to be SLP composition, SLP1 and SLP2, and that's very good sick beat practice to do this. So yeah, I mean, why not have it? So so now we need to do this bear of a function which looks up all of this stuff. We are making the assumption that SLP's elements do not themselves contain SLP. So really, this type should be something like and T not SLP, but you know, whatever. So evaluation. This is mostly just going through this and calling our constituent, our group functions, and that should be it. So we have SLP element, symbol. I'm actually just going to copy this. And here, so we have we do ADT match SLP with SL, you know, our object. So this first thing, just to say, is the type that we're matching against, and then this is the actual object, which just happened to be the same name. So if we have an SLP element, which is just X, we return X. We don't need a comment for that. If we have an SLP symbol, if we have a symbol S, then we evaluate SLP with our assignments of the SLP that we look up. So look up representation. Is that what I called it? No, symbol assignment. Symbol assignment within our assignment and our symbol S. but we should check that it actually exists. Let